Very good morning, children. And today we are going to start Hots questions on dual nature of light. Higher order thinking skill question, how to approach the problem. So we have learnt the content of dual nature and we know the concept of dual nature of matter and radiation. So light is considered to be two nature, which we have already learnt, that is particle nature as well as wave nature. Wave nature has been explained by means of hygienes, that is in wave optics. Particle nature mainly in photoelectric effect, and it is considered to be a small packets of energy called as photons or quantas. So all that we have learnt now, so we are stepping into the next level of doing problems as well as conceptual questions, that is competency based questions. So before starting off getting into that, so let us see some small tricks and tactics for doing it. So now let us recall other formulas, dual nature. So now dual nature, two natures, so wavelength of photon. So wavelength of photon. Recall the formula wavelength of photon. Wavelength of photon is lambda is equal to h by p, which is h by mv. That is wavelength of photon. Okay, Einstein photoelectric equation, recall Einstein photoelectric equation. That is h nu is equal to 5 plus half me square. You can also write h nu is equal to 5 plus ev naught, because kinetic energy can be written as ev naught, or I can also write h nu is equal to h nu naught plus ev naught, where work function is nothing but, when you recall the formulas, it will be easy for you to do any kind of problem, children. So even if you do not know anything about, at a scratch you are going to learn. So learn the concept as well. One topic concept you just learn, then immediately approach the problem by knowing the formula. So work function 5 is equal to h nu naught. What is nu naught called as, children? Nu naught is called as threshold frequency. That is called as threshold frequency. So we know work function. Next is de Broglie's wavelength. De Broglie's wave equation, that is lambda is equal to h by p, which is equal to h by root of 2m kinetic energy, which can also be written as root of 2m ev. But I wanted to find out de Broglie's wave length for electron. So let me write de Broglie's wavelength for electron. De Broglie's wavelength for electron. De Broglie's wavelength for electron. For electron, all concept we have already seen. So for an electron, lambda is equal to h by root of 2m ev. When I substitute the mass of the electron, charge of the electron, that will come around to be 12.27 Armstrong root v. This is the standard equation and the value is going to be constant. So we have seen that there are 5 important formulas. Apart from that, now according to Einstein mass energy relation, E is equal to mc square. So that can be written as mc into c. So therefore h nu is equal to mc into c, or I can write h nu by c is equal to p. So h nu by c is equal to p. This is also another equation. And also we have to know that 7th one, so we also need to know about the 7th one. Let me write here the 7th one, that is number of photons per second. Number of photons emitted per second. That can be written as power by energy. So that is equal to P by E, that is number of photons per second. So now what is intensity of radiation? Intensity is equal to power by, intensity is number of photon per second per unit area. So therefore intensity is equal to energy flux intensity, or you can call this as energy flux. Energy flux. In EM waves you have seen, no children, same thing, energy flux 5 is equal to power by area. Same thing over here, power by area, energy flux. So now keeping all that in mind, if you want to convert 1 electron volt value into joules, 1 electron volt is 1.6 10 power minus 19 children. So if you want to convert, you have to convert into joules, 1.6 into 10 power minus 19 joules, you have to multiply with. Now you get to know Hc by like lambda in joules, that is energy, which I am going to convert into electron volt, Hc by E into lambda in electron volt. What is Hc by E? So that is equal to 6.6 into 10 power minus 34. This is a standard value, we get to know 3 into 10 power 8 divided by 1.6 into 10 power minus 19. So when you add you here, you get 12.3 into 10 power minus 7 units. So therefore, if you know this value of Hc by E, you can easily do any kind of problem. So keep that in mind, Hc by E value is 12.23 into 10 power minus 7 units. So this is what we are going to use this for doing numericals. So keep that in mind here. Now let us start doing the numericals. So before doing the numericals, you have to have a comparative learning about charge and the mass. Comparison of charge and mass. Comparison of charge and mass of first proton, next deuteron, next is alpha particle. Children, do you get it? What am I going to compare? Only the mass and the charge. Children, how do you write proton, children? Proton is symbolized as H11, that is a symbol for proton. So let me write on the top symbol, that is proton. So now I know the proton symbol, next is deuteron symbol H12. Okay children, next alpha particle symbol He24. And which is charge here? The subscript is called charge, superscript is called mass. So charge, look at that. So let me write charge of it and then mass of it, compare. Charge is nothing but Qp, here also Qp, here it is 2 Qp. Whereas mass is nothing but Mp, which is a mass here. This 1, 2, 4 is mass. So that is Mp, here it is 2 Mp, here it is 4 Mp. That is all children. This is how we need to compare deuteron, proton and alpha particle. But then okay, how do you compare electron? Just get to know, note that charge of electron is equal to charge of electron is equal to charge of proton. So that is equal to 1.6 into 10 power minus 19 coulomb. So QE is equal to QP. What about the mass of electron? It is less than the mass of the proton. So you can approximately write it as 1 by 1840 times mass of proton. So therefore you can say mass of electron is lesser than that of the mass of proton. Similarly, also you can write it as mass of alpha particle is greater than that of the mass of proton. So all these basic things we know. Now we'll have to get into problems. Before that, you get to know kinetic energy is equal to EV naught. Specially you have to know maximum kinetic energy is equal to EV naught. What is V naught called as? Cutoff potential. And recall this Einstein photoelectric effect. How do you recall this Einstein photoelectric effect? According to Einstein photoelectric effect, that is particle nature of light, according to particle nature of light, when intensity of the incident light increases, Intensity is directly proportional to photocurrent. That is only in the case of particle nature of light. Intensity is directly proportional to photocurrent. Next, frequency increases. Frequency is directly proportional to kinetic energy of photoelectrons. Photoelectrons only when if nu is greater than nu naught. Also I can write frequency is directly proportional to stopping potential, or you can call it as cutoff potential. Cutoff potential. When is it possible cutoff potential directly proportional with frequency? Only if nu greater than nu naught. And photo emission is instantaneous. Children, what do you mean by instantaneous? There is no time lag between incident light radiation and ejection of electron. It's quite instantaneous. There is no time lag. So these are the laws of photoelectric effect. So you can very well understand that photocurrent increases only with respect to intensity, whereas it is independent of the frequency. Now let us start doing the first question. The electron and alpha particle have the same de Broglie wavelength. What is that? Same de Broglie wavelength. Okay. Associated with them, how are the kinetic energy related to each other? What is de Broglie wavelength formula? Here we have written lambda is equal to h by p, lambda is equal to h by root of 2m ek, h by root of 2m ev. But what formula I have to use? It is given here. Kinetic energies are related, same de Broglie wavelength. So lambda is equal to h by root of 2m kinetic energy you take. Because how are the kinetic energy related is asked, therefore you have to take it like that. So lambda electron is like that. So now lambda proton is equal to h by root of 2m into kinetic energy proton. Here it is electron. Same de Broglie wavelength. So therefore first equation is equal to second equation. Since 1 is equal to 2, so therefore h by root of 2m of electron, mass of the electron into kinetic energy of electron is equal to h by root of 2m into mass of the proton into kinetic energy of proton. So h get cancelled. Taking squaring on both the sides, you can get mass of the electron into kinetic energy of electron is equal to mass of the proton into kinetic energy of proton. So therefore, kinetic energy of electron divided by kinetic energy of proton is equal to what? mp divided by me. That is mass of the alpha particle divided by electron. P represent alpha particle. So if you want me to just change it as alpha particle, alpha you can write. So wherever you want change, so this is alpha. So here it is alpha. And here alpha. Wherever P is there, I am changing it to alpha. Okay. So I have represented as P. Now I am changing it as alpha. So I have just changed it as alpha. So mass of the electron and kinetic energy of electron is equal to mass of the alpha particle into kinetic energy of alpha particle. So when you divide mass of alpha particle by mass of electron. So this is the ratio, since m alpha is very much greater than that of me over here. So m alpha is much greater than that of me. You can see here. So therefore you can say, therefore kinetic energy of electron, Ek of electron is greater than Ek of alpha particle. So hope you understand this. How do you kinetic energies related to each other? This is how. Okay children, next we will go to the next question. What is the next question? Read. The stopping potential and experiment of photoelectric effect is 2 voltage. So V0 is equal to 2 voltage. What is the maximum kinetic energy of the photoelectron? What is asked? Maximum kinetic energy. The very first page I have told you maximum kinetic energy is equal to EV0. Same thing I am writing here. So we know that maximum kinetic energy is equal to EV0. So therefore V0 is 2 volt. Therefore I can write simply maximum kinetic energy is equal to 2 EV. That's all. It is in 1 mark question MCQ, it will be asked. Question. So show graphically the variation of de Broglie wavelength with potential V through which an electron is accelerated from rest. De Broglie wavelength is equal to h by root of 2m into EV. So lambda is inversely proportional to root V. So therefore variation of de Broglie wavelength with potential 1 by root V. 1 by root V, this is lambda. With potential V is asked. So, here V and then this is lambda. How is lambda varies with potential? Inversely, so like that you draw. So, you can write lambda is inversely proportional to root V. That's it. So, if you know the formula, you will be able to incorporate this graph. So, children, can we go to the next question? Yes, it will be very easy. In a photoelectric effect experiment, the following graph were obtained between the photoelectric current and the applied voltage. So, this is photoelectric current and applied voltage. Name the characteristics of the incident radiation that was kept constant and that was variable. You can see here 1 and 2 is not constant, that means this represent photo current is different, therefore intensity is different. Where is the intensity more? More the photocurrent, more the intensity. So, therefore, I1 is intensity is different, I1 greater than I2. So, I can write which is different, is intensity is different. So, how can I show you that? Like this you show. Okay, intensity is different, what is kept constant? You can see here, stopping potential is same. So, that means frequency is kept constant. Because I have already pointed out in this characteristics, we have pointed out here frequency is directly proportional to stopping potential. Same stopping potential, therefore same frequency. So, therefore frequency kept constant. So, what is the answer you can write here? What is the answer you can write here? You can write frequency of radiation and intensity of radiation. Frequency of radiation is kept constant, intensity of radiation varies. So, hope you understand. Yes. Next question. Can we go to the next question? A proton and alpha particle are accelerated through same potential difference. Earlier what have we seen? Same kinetic energy? No, same de Broglie wavelength kinetic energy relation. But here same potential difference. Which one of the two has greater de Broglie wavelength, lesser kinetic energy? Children, this question is no way connected to the graph. It is slightly different. A proton and alpha particle are accelerated through same potential difference. So, lambda is equal to h by root of 2m EV, or you can say QV. If you write like this, so half a mark you will get. Proton and alpha particle. So, lambda proton is equal to h by root of 2m proton q proton into V. This is equation 2. What is lambda alpha particle? Lambda alpha particle is equal to, I will just go to the next page. Yeah. So, lambda alpha particle is equal to, lambda proton is nothing but h by root of 2mp qp into V. Lambda alpha particle is equal to h by root of 2m alpha particle q alpha into V. So, here what is given? V is same. Is given the question V is same. Which one has greater de Broglie wavelength? So, now lambda p by lambda alpha. Lambda p by lambda alpha is equal to what? So, that is equal to square root of m alpha q alpha divided by mp into qp, which can be written as, earlier we have seen on the table, how is m alpha related, children? Have you seen that in the table? So, m alpha particle, how it is related? Mass 4 times. How does the charge related? 2 times. So, same thing you put it here, that is it. It is very simple. So, m alpha is 4 into mp and 2 times qp divided by mp into qp. That get cancelled, so that will be equal to root 8. So, therefore, lambda proton is equal to root 8 times the lambda alpha. So, what is the question here? The question is to find out which one has greater de Broglie wavelength. You can say here de Broglie wavelength is inversely proportional to mass of the charge. Lesser the mass of the charge, greater is the de Broglie wavelength. So, how much time it is greater? Root 8 times it is greater. Now, one more question lies, which has less kinetic energy. So, we know that kinetic energy is equal to Q into V. E into V, so that can be written as Q into V. V is same. How do you know? question it is given. So, kinetic energy is directly proportional to Q. Therefore, Q alpha particle is 2 times the Q protons. Therefore, I can say kinetic energy of alpha particle is greater than kinetic energy of proton. So, hope you understand how much times greater, children? 2 times it is greater. So, kinetic energy of alpha particle is equal to 2 times the kinetic energy of proton. So, hope you understand. I will just show you that. So, this is how we need to do this. Okay, children, you got it? Okay, so can we go to the next? It's very simple, a matter of half an hour you can complete it only if you know the concept and the formulas. Electromagnetic wavelength is lambda, an incident on a photosensitive surface of negligible work function. We know that Hc by lambda is equal to 5 plus kinetic energy. Okay? But work function is negligible. So, therefore, Hc by lambda is equal to kinetic energy, equation 1. If the photoelectron emitted from the surface of de Broglie wavelength lambda 1, but lambda 1 is equal to h by root of 2m into kinetic energy. So, therefore, substituting 1 into I am going to substitute by squaring. Lambda 1 square is equal to h square divided by 2m into kinetic energy, or h square divided by 2m into hc by lambda. 1h get cancelled. So, therefore, h lambda by 2mc. So, therefore, lambda 1 square is equal to this. Therefore, lambda 1 square is equal to h lambda by 2mc, or lambda is equal to what? Lambda is equal to what? You can write lambda is equal to 2mc by h into lambda 1 square. That is all. We got it. 2mc by h into lambda 1 square. This is actually lambda 1 square. So, hope you understand this is how you need to visualize the question, strategize the question and answer. This is very simple. Plot graph showing the variation of stopping potential with the frequency of incident radiation for 2 different photosensitive material having work function W1 and W2. So, this is work function W1, W2. W1 is greater than W2. So, therefore, I should write W2 here W1, because W1 is greater than W2. I have drawn x axis what you have, variation of stopping potential, y axis what you have, x axis frequency, y axis stopping potential. What is the significance of slope? The slope gives y axis divided by x axis. So, that is equal to, the slope is going to give y axis by x axis, or I can write slope is equal to y axis v naught, x axis nothing but nu minus nu naught 1. So, that is for metal A, metal 1. Similarly, v naught by nu minus nu naught 2s, that is equal to metal 2, that is nothing but slope. What is the significance of the slope? I have to find out no significance. Now, it is quite interesting. Do you know that h nu is equal to 5 plus E V naught? I want only V naught because in y axis V naught is there. So, h nu minus 5 is equal to E V naught. Therefore, V naught will be equal to h by E into nu minus 5 by E. This is in the form of y is equal to mx plus c. So, what is the significance of slope? Slope is, this is slope. So, this together you call it as equation 1. This together you call it as equation 2. Correlate 1 and 2. Compare 1 and 2. So, slope is equal to, I can say slope is equal to V naught by nu minus nu naught 1, which is equal to V naught by nu minus nu naught 2, which is equal to h by E. That is all. So, I get the significance of the slope, which is h by E. What is y-intercept? Y-intercept is minus 5 by E. So, I am writing here y-intercept that is equal to minus 5 by E. What is minus 5? Work function. So, minus work function divided by E. You can write it as W2 by E or W1 by E, whatever. So, hope you understand this. The given graph shows the variation of photoelectric current versus applied voltage for two different photosensitive material and for two different intensities. Can you see here intensities? Yes, two different intensities. And identify the pairs of curves that correspond to different materials. Same intensity. Intensity is same. What is same, children? We have seen no, intensity is directly proportional to photocurrent. Intensity is same and photocurrent is same. See here, photocurrent is same. But this is one metal, this is another metal. So 2 and 4 are different metals. Why? Because stopping potential is different. Similarly, when you take 1 and this is 1, this is 1 and this is 3. So 1 and 3 are different metals. Different metals. You got it, children? So different stopping potential, different metal, that's all. So we have done all that. Next. Following table gives the value of work function for photosensitive metal. So sodium 1.92, potassium 2.15, molybdenum 4.17. Each metal is exposed to radiation of wavelength 300. Which of them will not emit photoelectron? Tell me, children, what is the condition for emission of photoelectrons? H nu should be greater than work function. Or I can write Hc by lambda should be greater than work function. But I have already told you Hc by E I am going to convert into electron volt. So into electron volt convert. So Hc by E into lambda should be greater than work function. Children, what is Hc by E? We have learnt, no? Now only we learnt what is Hc by E here. I have given you. Where is that? Hc by E value, yeah, 12.3 into 10 power minus 7. They I am going to take. So 12.3 into 10 power minus 7 divided by lambda 300 nanometer. So 3 into 10 power minus 7. So get cancelled. 12.3 by 3 is that is equal to 4.1. 4.1 should be greater than work function. So 4.1 if it is greater than work function, then what will emit? Photoelectric emission takes place. PE takes place. PE takes place only if the incident light frequency should have greater than the work function. So 4.1 is greater than work function. Is 1.92 is there. 4.1 is greater. So H nu is equal to 4.1. H nu is 4.1 eV. But the work function is 1.92 eV, which is lesser than that of what? H nu. Of course, that is the photoelectric emission takes place, because what should be greater? Incident frequency should be greater, incident energy should be greater. Isn't that? Is the incident energy greater? Yes. So therefore, this photoelectric emission takes place, this also takes place, but this does not take place because it is 4.17. So therefore, does not take, molybdenum does not takes place. Does not takes place. Why does not takes place? Because work function is greater than that of the incident energy. Threshold frequency for certain metal is 3.3 into 10 power 14 Hertz. Nu naught is equal to 3.3 into 10 power 14 Hertz. And nu is equal to 8.2 into 10 power 14 Hertz. Predict the velocity of ejected electron and cutoff voltage. What do you do? I am going to give you only gist about it. H nu is equal to H nu naught plus EV naught. So H into nu minus nu naught is equal to EV naught. So 8.2 minus 3.3. So 4.9 into 10 power 14 into H. What is H? Planck's constant 6.6 10 power minus 34. It is advisable for you to know the value of Planck's constant, so that you will not go anywhere wrong. So divided by E is 1.6 10 power minus 19. So 1.6, 6.6, 4 times approximately, that is 4. So I will just put it properly itself so that I will get an idea. Yeah. So this is 6.6 divided by 1.6. So I am getting 4.125 into, this is 4.125 into 4.9. So that is equal to 20.21 into 10 power minus 34 plus 19, 23, so minus 33, so 10 power minus 1. Or I can write 2.021 voltage, that is equal to V naught. I know V naught, that is cut off voltage I found out. Then I have to find out the maximum velocity of the ejected electron. How to find out the velocity? Very easy, half mv square. Half mv square is equal to EV naught. So that is equal to V square is equal to 2 into EV naught divided by m. So V is equal to square root of 2 into EV naught. What is EV naught? 1.6 10 power minus 19 into 2. 2.0 is 2. Mass of the electron 9.1 into 10 power minus 31. So when you substitute approximately, so this is I am going to take this as 2 into 2 into this is 16 into 10 power minus 18. Minus 20 divided by 9 into 10 power minus 31. So therefore I can even write this as 90 into 10 power minus 32. So when you take out from the square root, you get 2 into 4 into 10 power minus 10 divided by, you can get 9 nines are 81. So what is the square root of 91? We will find out. So that is 9.5. So 9.5 into 10 power minus 16. So therefore I can write it as 2 4s are 8. So 8 divided by 9.5. So that will be 0.84. So therefore I will get 0.84 into 10 power 6 meter per second approx. You can check the calculation, children, and check it out and then find out. The work function of the two metal, that is nothing but 5A is given 1.2, 5B is given 2.4, which is double it. Light of the wavelength 600 nanometer falls. Which metal will give photoelectric emission? Already we have seen what is the condition for PE to take place. Hc by lambda into E should be greater than work function. What is Hc by E? Already we know that. That is 12.3 into 10 power minus 12.3 into 10 power minus 7 divided by lambda. Lambda is 600 nanometers, so 600 10 power minus 7 should be greater than work function. So approximately 2, and you get 2.5. So 2.5 you will get. Is 2.5 EV is H nu? Yes. So now H nu is 2.5, work function is 1.2. So this will take place. H nu is 2.5, but work function is what? 2.4. So absolutely we will find out because it is given very closer. So we will find out absolutely. So 12.3 divided by 6 is equal to 2.05. I am sorry, is not 2.5, it is 2.05. So since it is 2.05, this alone will take, this will not takes place. So while you are writing now, children, how to find out? How do you write? This is how you need to write. So I will just go to the next page. How do you write? First condition. Okay, professionally you have to write condition for PE to takes place. So H nu should be greater than work function, or you can write Hc by lambda in joules should be greater than work function, or Hc by E into lambda in electron volt should be greater than work function. So what is Hc by E? 12.3 into 10 power minus 7 divided by lambda is what is lambda? 600 nanometers. So 600 6 into 10 power minus 7 EV should be greater than work function. So that is 2.05 EV should be greater than work function. So therefore metal A, you can see here, this is metal A will undergo PE, metal will not, B will not undergo. So metal A will give photoelectric effect, PEE. So therefore what can you write? Here in this case, which of the metals will give photoelectric emission? What will you write, children? Which one? A. What is the maximum velocity and cut-off potential? That we will do. Maximum velocity and cut-off potential. Okay. So work function is given and H nu we find out. We found out now H nu 2.05. So H nu is equal to 5 plus EV naught. What is H nu? 2.05 EV. And what is work function? 1.2 EV plus EV naught. What is 2.05 minus 2.05 minus 1.2 EV? 0.85. 0.85 EV is equal to EV naught. E get cancelled, therefore V naught is equal to 0.85 volts. So we found out cutoff potential. By knowing this cutoff potential, you can find out the maximum velocity. The same method that you can just leaving to you, you can do it. If the source is moved away, how does it affect the stopping potential? Children, if the source is moved away, what will happen to the brightness? What will happen to the intensity? If the source is moved away, the intensity reduces. And if the intensity reduces, photocurrent reduces, but nothing to do with stopping potential, because we have already seen that the frequency only is directly proportional to stopping potential. We have already seen that. Okay? Frequency changes, stopping potential accordingly changes. But here, if the source is moved, only the intensity varies. So therefore, since intensity varies, how does it affect? No change. Only the photocurrent change accordingly. So hope you understand this. And then, so we will go to this. Light of frequency 2.5 nu naught. Frequency. Please underline the word frequency. Is incident on a surface of threshold frequency nu naught. And the photoelectric current is 1 milliamps. Nu is equal to 2.5 nu naught. And threshold frequency is nu naught. Photoelectric current is equal to 1 milliamps. If the frequency of the light is halved, now you tell me if it is halved, what will happen to the incident frequency? Incident frequency is still greater than the threshold frequency. Nu dash will be equal to 1.25 nu naught. So hence emission takes place. Emission takes, but intensity is doubled. Emission takes, photocurrent doesn't change with this frequency. But what is doubled here? Intensity is doubled. So when intensity is doubled, photocurrent also doubles. Hence IP doubles. Do you get it, children? Because intensity varies, photocurrent varies. So when intensity doubles, photocurrent doubles. That's all. But frequency vary, increase or decrease, nothing, no way it is connected with the photocurrent. But see to the photoelectric emission takes place. Here it is taking place is more than 1. Otherwise, if less than 1 doesn't take place. So the graph below shows the variation of stopping potential versus frequency of the incident radiation for 2 different photosensory material. Express the work function. So now slope is equal to, I will find out the slope, that is equal to stopping potential V naught divided by nu minus nu naught 1, that is for the first one. Second one, V naught divided by nu minus nu naught 2, that is second one. So we know that h nu is equal to, that is h nu naught plus EV naught. So therefore I can write h into nu minus nu naught divided by E is equal to V naught. So therefore V naught is equal to, you can write V naught by nu naught minus nu naught, or you can write V naught by nu minus nu naught is equal to h by E, which is nothing but slope. So we found out slope V naught by nu minus nu naught 1. Similarly here also you can write V naught by nu minus nu naught 2. So that's equal to h by E, which is equal to slope. So if you want you can show that, I will show you that. Got it? So slope I found out, and h is the Planck's constant, right? So express the work function m1 in terms of, therefore work function is equal to, work function, here I have to write same way, V naught is equal to, EV naught is equal to h nu minus 5. So therefore V naught is equal to h by E into nu minus 5 by E. So therefore, and you have to write the work function in terms of Planck's constant. So therefore work function in terms of Planck's constant, I can write here by using this equation, V naught is equal to y is equal to mx plus c. So work function is 5 is equal to h nu naught over here. So wherever nu naught is there, I can write it as h by 5. So how do you write children, h by 5? So can I just show you that? Yeah. I will take the inside textbook and then I will show you the same thing. Yeah, children, you can see that. So, h nu naught 1 by E, and this is h nu naught 2 by E, and V1 is equal to h by E into nu minus h by E into V naught 1, because V1 is nothing but h nu minus h nu naught 1. So, that is how we need to do it. So, we will just go back to that board and then you can get this. Yeah, so like this. So, you can learn the same thing. Same thing I have given in the same way. So, you can see here this is work function here, which can be written as h nu by E, h nu naught 1 by E, and work function 2 is h nu naught 2 by E. So, V1 is equal to h nu by E minus h nu naught 1 by E. So, that is nothing but EV naught is equal to h nu minus h nu naught, right. So, that is what V naught is equal to h by E into nu minus h into nu naught by E. So, this is h nu by E, h nu naught 1. Similarly, here V naught 2 is equal to h by E into nu minus h into nu naught 2 by E. So, that is what. So, hope you understand this, children, and same way here you can do this. Monochromatic light of frequency is given. So, that is equal to 6 into 10 power 14 Hertz. The power emitted is given as 2 into 10 power minus 3 watt. What is the energy of the photon? Use the formula E is equal to h nu and get it 6.6 into 10 power minus 34 into 6 into 10 power 14. So, that is equal to 39.6 into 10 power minus 20. So, that is joules, or you can write 3.96 into 10 power minus 19 joules. So, that is energy. How many photons per second have we already seen that photon is equal to power by energy. So, that is equal to power is 2 into 10 power minus 3 divided by 3.96 approximately I am taking as 4 into 10 power minus 19. 2 by 4 is 1 by 2, 0.5. 0.5 into 10 power plus 19, so 16 per second. That is all, children. So, now this is how we need to do it. In the last one, if 5% of the energy is supplied, how many visible quantas are emitted by 100 watt? So, this is also number of photons per second is asked. So, that is equal to power by energy. 5% of the power, 5% of 100 watt divided by energy is nothing but Hc by lambda. What is lambda? 5000 Armstrong. So, 5 by 100 into 100 divided by Hc by lambda. So, that is nothing but 6.6 10 to the power minus 34. C is 3 into 10 power 8. Lambda I am taking it up 5 into 10 power minus 7. So, when you substitute 100 get cancelled and you will get 1.41 in 10 power 19 joules. So, hope you understand, children, and thank you, children. You can just learn that by writing, and if you have any doubt you can always reach me. Thank you, children.